Alright, I got some good news for you. Today's lesson is on 5-6, the quadratic formula, and talking about the discriminant. Now, it's good news because after a lot of intense lessons, this will be a nice, easy review for you. Alright, so you probably have the quadratic formula memorized. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. When we want to evaluate the quadratic formula, we use the a, b, and c value, again coming from the standard form of ax squared plus bx plus c. So when we look, we've got that our a value is 1, our b value is a negative 3, and our c value is a negative 40. We plug it in. This is the opposite of b. b is a negative 3, so the opposite of a negative 3 is a positive 3. Plus or minus the square root of b squared, negative 3 squared, minus 4 times our a times our c, all over 2 times our a value. So the very first step, and you want to make sure that you show all of your work for this, is substituting in your a, b, and c value. Don't skip this step or you're going to skip a point. Then what we want to do is we want to simplify this quantity inside that square root sign. And you want to make sure that you have the parentheses where they need to go and how they need to go. And that ends up being 169 all over 2. In this case, 169 is a perfect square. The square root of 169 is 13. So we've got 3 plus or minus 13 all over 2. That gives us two solutions. One when we add 13 and one when we subtract 13. So we've got 16 over 2, which is 8, negative 10 over 2, which is a negative 5. So for this case, we have two solutions. X is equal to 8, or x is equal to 5. One of those two cases will both give us an answer of 0. Don't forget that when you graph this, your solutions are your x-intercepts. So go ahead and pause and get out your calculators and graph it and look at your picture. Alright, we have our equation into y1. We go to zoom 6. We start off with a standard window. We got to move our window down. So that's our y. And let's move that down. I'm going to make it negative 30. See if that fits. No. But good enough for me for right now. We can see where the sketch is going to be. And we see that our graph is opening up, which we would have been able to tell from our a value. We have our two intercepts. Go to second trace, we find the intersection between the line, and then our second curve, we should have 0 and y2. And we get that our first one is at negative 5, 0. And good thing we did this so we can check our answer. Scroll over. If you just hit enter again, you'd get the exact same answer. And we get that our second one is at 8, 0. So I missed that negative. So negative 10 divided by negative 2 is a negative 5. So don't be like me and make sure that you're paying attention to your positive and negative signs. We see that we have two solutions. We have two x-intercepts. We go on to our second one. 3x squared plus 2x equals a negative 5. In order to use the quadratic formula and to find the correct a, b, and c values, you need to have your equation in standard form. So we've got to move that 5 over from the right to the left, where it becomes a positive 5. So a is equal to 3, b is equal to 2, and c is equal to 5. So we want the opposite of b. The opposite of a positive 2 is a negative 2, plus or minus the square root of b squared minus 4 times your a times your c all over 2a. Remembering your first step is always just to show the substitution. So we plug in our a, our b, and our c value everywhere, making sure that we don't skip that so that you get all your points. Next thing we want to do is simplify this number underneath the square root sign. So we got negative 2 plus or minus the square root of a negative 56. Now, if I have a negative inside my square root sign, I know that I have imaginary numbers. I break down 56. We've got 8 and 7, 4 and 2, 2 and 2. So that becomes a negative 2 plus or minus 2i on the outside, 14 left over on the inside, with a 6 on the bottom. Now we've got 3 pieces. All 3 are divisible by 2. If not all 3, then you can't do one of them. So it becomes a negative 1 plus or minus 1i root 14 all over 3. And no, you do not have to have that 1 there. You need that 1, but you have the I component, so you'd have an assumed 1 there. We go to our graph. We plug in 3x squared plus 2x plus 5. Go back to our standard window, zoom 6. And when we graph it this time, we see that our parabola is up here. There aren't any x-intercepts, and that's why we don't have any real solutions. These are imaginary solutions. Remember, there's a difference between real and imaginary. Since the negative is on the inside, we have imaginary solutions but no real solutions. So I don't have any x-intercepts. We look at our next quadratic formula question. Again, we want to start in standard form, so we've got to move everything over. So we've got 2x squared minus 12x plus 18. I always make it so that my x squared term is positive. If not, you're going to have a couple more problems there. So we have a is equal to 2, b is equal to a negative 12, and c is equal to 18. I want you to press pause and go ahead and try doing the quadratic formula and graphing this last one. Alright, let's see how you did. First, double check, make sure that you have all of your numbers substituted in correctly. When you break down that radical, those numbers inside, you get a 0. Well, the square root of 0 is just 0. And it doesn't matter if you add 0 or subtract 0, the top number is still going to be 12. 12 divided by 4 is 3, giving us one solution at 3. When we graph this, we see that we have one x-intercept at 3, 0. So we have 3 different cases here. We had a graph that had 2 x-intercepts, a graph that had none, and a graph that had 1. And we noticed that in our first one, we had 2 x-intercepts, 2 solutions. No x-intercept, we had no real solutions. We have 2 imaginary solutions, but no real. And last, we have 1 solution and 1 x-intercept. On the back page, we are going to look more closely at the discriminant. And the discriminant is b squared minus 4ac. If you remember the quadratic formula from the previous page, the discriminant is simply the piece that is inside that square root sign. So the discriminant is just that number that's going to end up underneath the square root. The discriminant is going to tell us a lot about our problem. When we look back at the first example, flipping back and forth here, the number underneath the square root sign was 169. It was a positive value. And when you took the square root of that positive value, you added a number and you subtracted a number. So when the discriminant was positive, we got 2 real solutions. On the second example, we had the discriminant was a negative 56. When it was a negative, we added, subtracted, but that was an I value, so we had 2 imaginary solutions. And our last problem, the discriminant, the number underneath that square root sign, was a 0. And when the discriminant is a 0, we had 1 real solution. So you can determine how many solutions you're going to have simply by looking at the discriminant and the discriminant only. We look down at the bottom, find the discriminant, and state how many solutions it has. So we need to look at the a value, the b value, and the c value. And remember, this is just b squared minus 4 times a times c. So we've got 6 squared minus 4 times 9 times 1. So our discriminant value here, 36 minus 36, the discriminant value is 0. And according to our chart up here, if the discriminant is 0, we have one real solution. We look at the second one. We move that 4 over to get 9x squared plus 6x minus 4 equals 0, giving us a is 9, b is 6, and c is a negative 4. We square our b minus 4 times a times c, and we've got 36 plus 144, because minus a negative. We get d is a positive 180. Since our discriminant value is positive, we're going to have two real solutions. And last but not least, our a is 9, our b is 6, and our c is 5. So we've got 6 squared minus 4 times a times c, which gives us 36 minus 180. So our discriminant value is a negative 144. Because it is a negative number, we're going to have two imaginary solutions. So just by looking at the number that's underneath the square root, we're going to determine how many solutions the equation is going to have in the end. Alright, one last thing, and it's kind of cool, so you may want to pay attention here. Alright, so what I'm going to show you now is where the quadratic formula actually came from. So we're going to start with the quadratic equation in standard form, and we know that our quadratic equation in standard form is ax squared plus bx plus c. There are so many different ways that you can solve a quadratic. The one that we talked about today is the quadratic formula. One that we talked about the last couple days before that is completing the square. No matter what the quadratic equation is, you can always use the quadratic formula or completing the square to find your solutions. Sometimes you can use factoring. Factoring is easier and much faster, but it's not always going to work. So I'm going to use completing the square to derive where the quadratic formula actually came from. And if I'm going to be completing the square, I know the first thing I'm going to do is take that c value and I'm going to move it over to the other side. So I've got ax squared plus bx is equal to a negative c. Now I know that in order to use completing the square, I need to have my first term to be a positive 1x squared. So I'm going to factor out that a value, which means I'm left with x squared. When you factor something out, you are dividing by that. So that middle term, even though it's a letter, is going to be b divided by a. So the same thing, sometimes we kind of freak out when we have letters instead of numbers. It's still going to be the same process every step of the way. Now I want to actually complete the square, create that perfect square trinomial, and we do that by taking half of the middle term. Well, if I have b over a divided by 2, that's the same thing as multiplying by the reciprocal. So that's b over 2a, so it's half of the middle term, and then we square it. So I've got b squared, and when I square 2a quantity, I've got 4a squared. Now if I add that on the left, I have to also add that on the right. The only difference is I have a of those quantities, so I've got to multiply a by that as well. And doing that, even though I know it doesn't seem like it, is actually going to make things easier, because I have an a on top, which is going to cancel one of the a's on the bottom, so this is a negative c, plus b squared all over 4a. On the left-hand side, what we just did is we created that perfect square trinomial so that I could factor it. And we know that this is going to be the factor, the perfect square binomial there. We got that same quantity twice. Before we start solving for x, I want to combine the two pieces on the right as one. In order to do that, I need a common denominator. The first piece is not a fraction, the second piece is. So I know that the common denominator there is going to be 4a. That means the second piece is not going to change, so that stays as b squared. But I would have to multiply the top and bottom by 4a here. So that becomes a negative 4ac all over 4a. Now that they both have the same denominator, I can combine it together, a negative 4ac plus b squared all over 4a. So I'm going to rewrite that together. On the left, we've got a times x plus b over 2a, quantity squared. Now, hopefully you see that that's looking pretty familiar to you, so I'm going to do b squared minus 4ac. All I'm doing is switching those two terms all over 4a there. Now we want to get x by itself, so we divide both sides by a. Now we know, just like up here, the same thing, if you divide by something, you can multiply by the reciprocal. So the reciprocal of a is 1 over a. It's going to make things a little bit easier for us. So we've got x plus b over 2a, quantity squared. And we have the a, so we've got b squared minus 4ac all over 4a squared. Now, in order to get to the x, we have to square root both sides. And that leaves us with x plus b over 2a on the left. On the right, we can't break those two pieces up, so that's going to be the numerator, b squared minus 4ac. On the bottom, 4 is a perfect square, and a squared is a perfect square, so that becomes 2a. Now the only thing we have left is to subtract, we square root both sides, can't forget our plus or minus, subtract b over 2a from each side, and we've got x is equal to a negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. How convenient, both of our numerators are exactly the same, our denominators are exactly the same, so I can combine this together, and we've got the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So from using the completing the square method, we actually just derived where the quadratic formula comes from. Pretty cool, huh?